So here's the UH quiz, right triangles and sectors. This is going to be like a really good review for the semester. It has a lot of pretty much everything except for like the trig identities. And I think you're going to like it. You'll see all the stuff that we've been working on. So here it is, guys, right triangles and sectors, and let's give it a shot. It says in right triangle ABC, so I'm going to draw a triangle. So here's my triangle. And it says with right angle C, so I'm going to write A, B, C. AB is 11, so I put 11. And it says BC is 2. BC is 2. Find the length of the missing side. So here it is. So all I'm going to do is Pythagorean theorem. So I'm going to go x squared plus 2 squared equals 11 squared. I'm going to move the 2 squared to the right. So x squared equals 11 squared minus 2 squared. So let's see. X squared equals 11 squared is 121 and 2 squared is 4. So x squared equals the square root of 117. And I guess you can let the answers give you the answers, but let me show you the right way to do it. So what I would do, I would figure out numbers that multiply to give you 117. And how would I do that with a calculator? Like this. I would go to y equals, and look, there it is. There's actually a hint. 117 divided by x. So that means x times y equals 117. Do you guys see that? And then I just go to the table, second table, and there it is. These two numbers multiply to give you 117. So I'm just going to look for the biggest number, the biggest perfect square root. And there it is, 9 times 13. So this is the same thing as 9 times 13. 9 is a perfect square root. What's the square root of 9? So 3 square root of 13. There it is. Do you see how we did it, guys? You could always let the answers give you the answers. Chav, what does that even mean? Let the answers give you the answers. You could go square root of 117, and then see it's this decimal 10.8166, and then you go to letter A, it says 10 square root of 5, and then you go 10 square root of 5, and see it gives you 22.36. Obviously, D is the correct one, so if I put 3 square root of 13, it'll give me that. So watch. 3 square root of 13, and there it is, 10.81. Do you guys see that, guys? Okay, so that's letting the answers give you the answers, but there's a right way to do it. Here's the way I would do it. I would just get two numbers that give you 117 and give me the biggest square root. All right, next one. In a right triangle ABC, so again, they have a right triangle right here. So right triangle, not to scale, with right angle C, so I'm going to call it ABC. AC is 12, so AC is 12. BC is 4. Find the length of the missing side. So now they want the hypotenuse. So you're going to go 12 squared plus, 4 squared equals, and then what's 12 squared? Plus 16 equals x squared. 144 plus 16, 44, 54, 160 equals x squared. Then square root. X equals, let's see, 160 is the same thing as 10 times 16, right? And then the square root of 16 is, so 4 root 10. Oops. I accidentally pushed the zoom in button. 4 root 10, and there it is. How do we feel, guys? All right, let's go to the next one. This is an isosceles right triangle. If you have an isosceles right triangle, guys, this is 45 degrees. This is 45 degrees. Yep. So I could use the 45, 45, 90 degree property. They tell you that AB is 11. So that means the hypotenuse is 11. So that means I can put an 11 right there. So n root 2 equals 11. You want n, because that's what that is. Does that make sense, guys? So I just divide by square root of 2. Divide by square root of 2. N equals 11 over square root of 2. Rationalize the denominator. So multiply this by square root of 2 over square root of 2. So 11 root 2 over 2. That's not the only way to do it. You could have done it with Pythagorean theorem also, but I think it's easier that way with 45, 45, 90 properties. Stop me, guys. Stop me. Oh, I saw this, and then there's a right angle here. So an isosceles right triangle. So if it's an isosceles right triangle, 45, 45, 90. Okay. All right. Let's go to the next one. Yeah, this is an isosceles right if you want to write that number or write that name down. This is the 45, 45, 90 because they give you one of the angles and they give you the 90. So that means this is also 45 degrees. So we're doing the same thing. AC is 6 square root of 3. So if anything, this is actually kind of a simpler one. 45, 45, 90, and square root of 2. This is one of the sides. So this is like 6 square root of 3. You can if you want, but it's easier to just go from a leg to the hypotenuse by just multiplying 6 root 3 by square root of 2. See? So the x is going to be 6 root 3, and I'll just multiply it by square root of 2. So 6 root 6. And there it is. Is that cool, guys? Yay! We're already in question 5. All right. In the figure below, an altitude is drawn to the base of an equilateral. Okay, so an altitude, so here it is. That's like your height near that. And triangle ABC, if AC equals 8, so it's an equilateral, guys. So that's 8, that's 8. Both of these together is 8. Find AB. So this cuts it right in half. So A is 4 and B is 4. Does that make sense, guys? And there it is. So you could have also used the properties of a 30, 60, 90 triangle. N square root of 3, 2n. So they give you the 2n, the 8, divided by 2, 4. See? We'll do it on this one. Question 6. In the figure below, an altitude is drawn to the base of an equilateral triangle, just like before. If AC is 13, so that means this is 13, and this is 13. Find C, the length of the altitude. Okay, so they want this guy. A is half of 13, so A is 13 over 2, and so is B. And Cha, what are you doing? Well, that is just half because we know that, right? And n square root of 3 and 2n. And then to get the height is, this is like your long leg, see, 60 degrees. So I take the 13 over 2. This is what it was 13. So it's 13 over 2. And I just multiply it by root 3. 13 over 2 with a root 3 on the side. Well, I have to get the short leg first before I can get the long leg. So this is my short leg. Also, too, this is also an equilateral triangle. So this is 13, this is 13, this is 13. This cuts it in half, so that's 13 over 2. This is 13 over 2. And then the long leg, I just have one side by square root. Cool? Okay. All right. Are we cool with this one, guys? Yay. Another happy face. Okay. Let's go to the next one. Yes. The long leg created, the 60 degrees created the long leg. Okay. Triangle ABC is shown if AC is 13, so AC is 13. Find X and Y. Again, it's a 30, 60, 90 triangle. N root 3, 2n. That 13 is the long leg. Do you guys see that? So I put 13 there. 13, not 13 degrees. So yep. N square root of 3 equals 13. Divide by square root of 3. Divide by square root of 3. So n equals 13 over root 3. Rationalize it. Okay, tell me. This guy, n root 3 is the long leg. This is the long leg. So n root 3 equals 13. Yeah, but how do you get the long leg? Well, I have to divide. All right, so that right there that we got is your short leg, which is y. So this is y, 13 root 3 over 3. And then all you got to do to get your x, which is the hypotenuse, is double it. So 13 root 3 over 3. So what's 13 times 2? So 26 root 3 over 3. And we look for that. There it is. What's up, Dulce? We just multiplied it by 2. It says 2n right here. So if you go 13 root 3 over 3 and you multiply it by 2, it turns to 26 root 3 over 3. No, ask. It's all good. No, 3 does not go into 26. Cool. All right, the next one, guys, we're in question 8. AB is 4 root 2. So again, a 30, 60, 90 triangle. So maybe UH loves these triangles here. N square root of 3, 2n. That's hypotenuse. So I'm gonna write the expression 2n. 2n equals 4 root 2. In case you don't know why I'm writing 2n, guys, is because that's the expression that signifies the hypotenuse. The 60 degrees, this guy is n root 3, and the 30 degrees is your short leg, so this is n. See? So all I got to do to get n by itself is just divide by 2, divide by 2, divide by 2. 4 divided by 2 is 2, so n equals 2 root 2. Do you guys see what I did? So that n equals 2 root 2 is the same thing as x. So x is 2 root 2. Now to get the long leg, all I take is I take the small leg, the 2 root 2, and I multiply that sucker by square root of 3. So y equals 2 root 2 multiplied by square root of 3. So you get 2 root 6. Laws of exponents. So square root of 2 times square root of 3 is square root of 6. Are we doing okay, guys? I look for that answer, and there it is.
And then 45, 90 would be n, and then n right equals 2, right?
Yes, n square root of 2. All right, so on this one, they draw a triangle, not to scale. They tell you that. And they tell you segment lengths. So they tell you that DF is 41, so I'm going to put 41. And they tell you that EF is 40, so 40. So what I'm going to do is I'm going to find DE. I'm going to use the letter X. So here we go. X squared plus 40 squared equals 41 squared. I'm going to move the 40 squared to the right. X squared equals 41 squared minus 40 squared. I take my calculator. I'm going to go 41 squared minus 40 squared. See what that is. And bam, 81. It's going to be a perfect number then. Yep. X squared equals 81. When you take the square root, X equals 9. So this guy is 9. So get it here first. Let's see, what did they want? Okay. Write SOHCAHTOA. So by now, hopefully this is super easy because you've seen it in physics and we did it in pre-calc. And it says cosine of D. So cosine of D. Go to D. Bam. Cosine is adjacent over hypotenuse. What's the adjacent? 9 over 41. Okay, we got that one out of the way. Now it says tan F. So go to F. Exaggerate the angle. So there it is, F. Tangent is what over what? Okay, so what's opposite? What's adjacent? There you go. Look for those answers. If they reduce, reduce it. But if they don't, look for those. And there it is. Look at you guys being nerds. Man. I'm disappointed in you. No, that guys, I'm going to take that out because those are hard words. I'm not disappointed in you guys. I am, my heart is full there. Because you guys are nerds. That's cool, right? All right. You guys are so funny. All right. Suppose that theta is an acute angle of a right triangle and tan theta equals 4 squared root of 2 over 5. Okay. SOHCAHTOA. I'm going to draw a triangle. And here's my angle. Tangent is opposite over adjacent. So opposite to that is 4 square root of 2. and adjacent to that is 5. Do you guys see what we did? Okay. I need the hypotenuse. So I'm going to go, I'll call it x. So I'm going to go 4 square root of 2 squared plus 5 squared equals x squared. Have I confused anyone? Okay. So let's see. 4 times 4 is 16. 16 times 2 is 32. So that's 32. Relax. If you don't know that, just type it in the calculator. But I would like for you guys to know that. 5 times 5 is 25. So let's see what that is. 20, 32, 42, 52, 57. So 57 equals x squared, square root. X equals square root of 57. It does not reduce. Notice there's a whole bunch of square root of 57s in there, so that's kind of giving you a hint as well that it doesn't reduce. So this is square root of 57. Are we still okay, guys? Okay. I'm going to write, let's see, I'm going to write it in blue. I'm going to write sine theta. Sine is opposite over hypotenuse, so opposite is 4 root 2, and the hypotenuse is root 57, square root of 57. Rationalize it. Multiply that sucker by square root of 57 over square root of 57. And you're going to get 4 square root double 57. What's that, 114? Excuse me. And there it is. 4 square root of 114 over 57. They don't reduce because 4 and 57, 4 is even, 57 is odd. So leave it alone. And look for that answer for sine. Okay, now we need cosine. So I'm going to use cosine in, what do you call this color? Purple or violet? I'll do it in black. So cosine. Cosine theta equals adjacent 5 over hypotenuse, square root of 57. Do you guys agree? Rationalize it. So multiply it by square root of 57 over square root of 57. And you get 5 square root of 57 over 57. And there it is. Are we feeling okay? Okay. What's up, Hornbeck?
Oh, no, I just can't see.
Oh, okay. Go to the next question, next page. It's kind of the same thing, guys. So we have a common theme here. So draw a right triangle. They tell you that secant is 9 over 4. Secant's a reciprocal of cosine. So I'm going to say that this is my theta. And cosine is adjacent of our hypotenuse. So I'm going to put the 4 here and the 9 there. So now I'm going to figure out this length, that x. Pythagorean theorem. 4 squared plus x squared equals 9 squared. Move the 4 squared to the right. X squared equals, let's see, 9 squared is 81 minus 16. Yeah, I think that's easy enough to do. 81, 71, 61, 65. I do it in pieces. I subtracted 20 and then added 4 because 16, right? So then square root. X equals square root of 65. And because I'm seeing square root of 65 all over the place, it does not reduce. Leave it alone. Are we still okay? All right, we're ready now. Sine theta. Sine is opposite over hypotenuse. Opposite, square root of 65. Hypotenuse 9, it's already set up. So look for that. Cotangent. Chav, I don't know cotangent. It's not in SOHCAHTOA. It's a reciprocal of tangent. So tangent was opposite over adjacent. So cotangent is adjacent over, opposite. So bless you. So it's going to be 4 over square root of 65. When you rationalize it, 4 square root of 65 over 65. All right, let's look for it. And here it is. Chav, the sign looks weird with the 1/9. Yeah, I know. The door's always... Yeah, put it in the fridge. All right. Guys, everyone's okay with that 1/9 there? Square root of 65 over 9 is the same thing as 1/9, so the square root of 65 on the side. I don't know why UH did it that way. Maybe their software, maybe, somehow the way that they represent numbers, but just make sure you're aware of that. Okay. Question 12. Check this one out, guys. 120 degrees. What is it in radians? 2 pi over 3. If you don't remember that, you can just go 120 degrees, multiply it by pi over 180. So 6 goes into 12 twice. 6 goes into 18 3 times. 2 pi over 3. Yay. Let's go to the next one. Convert the following radian measure to degrees. Child, this one's done in the unit circle. I don't know what it is. Relax. 8 pi over 9 times 180 over pi. Pi's cancel out. Take your calculator. Go 8 9 times 180. So here it is. Alpha y equals, using the little fraction feature, 8 9 times 180. There it is, 160. Bam. Are we doing okay so far, guys? Are we doing all right, nerds? Okay. Don't give me a thumbs down, YouTube. I mean it with love. All right. Here we go. Question 14. What, you guys talking smack? I think you literally are. Sorry. I don't think it's a okay. Don't worry, real quick. Do you remember there was a phase where everyone was saying, "I can't even." Do you remember? And every time they would say that, I remember. I'll never forget. This was at Southside, and it was a volleyball player, and she's like, "I can't even." And I remember I was not trying to be silly. I was just, it was like one of those days, and I look at her and I'm like, "Can you odd?" Like, and she's just like, I'm like, "Come on, miss, let's keep going." Yeah. Okay. All right. Let's see what this says. To find the length of the arc of a circle, think of the arc length as simply a fraction of the circumference of the circle. If the central angle theta defining the arc is given in degrees, then the arc length can be found using the formula. Wow, look at UH teaching us stuff. You don't think that's cool that they wrote all that? They didn't have to. Let's read that again. Look. To find the length of the arc of a circle, think of the arc length as simply a fraction of the circumference of the circle. If the central angle theta defining the arc is given in degrees, then the arc length can be found using the formula. Bam. So what they're trying to tell me is this. This theta over 360 is like a percentage. Like a percentage of your circumference. Circumference of a circle is 2 pi r. So look, see, they give you theta over 360 like a percentage and then multiply it by the circumference. That's very smart. Thank you, UH. Isn't that cool? So it says use the formula to find the arc length S, where theta is 330 degrees. Chav, I don't know what arc length is. Yeah, you just plug it in. Arc length is this, guys. Like finding this distance. See, they're telling you that they're giving you this angle. See, like that. Well, this one is pretty big. This one's 330 degrees. So that one looks like Pac-Man. Yeah, let's find it. So here we go. So I'm going to go arc length S equals 330 degrees over 360 degrees. That's like a percentage. Times 2 times pi times 7. Take your calculator. Notice that all the answers have a pi in them. So do not insert pi in the calculator. Just do this. Go alpha y equals 330 over 360. There's like my percentage. And I'm going to go times 2 times, don't write pi, times 7. And then hopefully it'll give it to me in fraction. There it is. Just put a pi in the numerator. 77 pi over 6. Arc length equals 77 pi over 6. For you visual learners, what did we find? We found this. So let me go ahead and write this big. We found 330, so it's like right there. So we found this is 330 degrees. You found all this in black. You found this in black. Call that S. You found all that in black. The arc length. Cool or not cool? Cool. All right, let's go to question 15. If the central angle theta defining the arc is given in radians rather than degrees, then the arc length can be found using the formula. Check that out. The 2 pi's cancel out, which simplifies to S equals arc theta. So this is why sometimes radians is superior over degrees. Look how simple that formula is. It's just arc theta for arc length. Isn't that so cool? Now you guys are like, okay, whatever. All right. So look, let's see. Let's figure out the arc length or the arc length S here. So S equals 11 pi over 6 times 7. Well, 11 times 7 is 77. So 77 pi over 6. And there it is. The theta over 2 pi is like a percentage, but there's already a 2 pi there, so the 2 pi's canceled out. Yep. Yeah, that's what makes this super strong. All right, question 16. Now they use a special word, perimeter. Find the perimeter of a sector of a circle with central angle 11 pi over 6 and radius 8 feet. All right, let me give you a visual of what they want. Here's what they want. The radius is 8 feet. That's 8. And then I'm going to go all around. It's practically almost 2 pi. So that's theta equals 11 pi over 6. So this is going to look like Pac-Man. And that's 8. I didn't draw it super perfect, but I'm pi over 6 away from a full revolution, from a full circle. And that's what they want, guys, the outline. Everything in, I guess everything here in green. Everything in green is what they want. So let's add them up. 8 plus 8 plus the arc length. How did I find the arc length? Well, I just did it right now. This is just r theta for the arc length. So my radius is 8, so I'll go 8. And the angle, the central angle, is 11 pi over 6. So let's see. 16 plus 8 times 11 is 88. I guess I could have also reduced it. Oh, because that's a perimeter. It's like if this were a bird's eye view, that's like the fence, right? 8, like how much fencing you need. 88 over 6 reduces to 44. Oh, I put a plus. 86, 16 plus 44 pi over 3. 2 goes into 88 44 times. 2 goes into 6 3 times. And look for that answer.
What's the formula for perimeter?
Perimeter just means add everything around. Yeah, don't think about formulas. Just think about what the word perimeter means. Like, say it again. Oh, because I just did it in the previously. That's what they told me that how to get arc length, arc theta.
Oh, yeah.
Are you good?
Oh, so you're adding the.
Yeah. Yeah, perimeter just means everything in the exterior, right? Okay. And no yawning, that's a demerit. Okay. No, someone over there yawned. Yeah, right now. All right, guys, let's continue. We only got 3 left. To find area of a sector of a circle, think of the sector as simply a fraction of the circle. All right, guys, focus. If the central angle theta defined in the sector is given in degrees, then the area of the sector can be found using the formula. Guys, I think this is brilliant. I love how they're explaining it and not just telling you. This right here is like a percentage. Like a percentage. And everyone, I hope you know, but if you don't, that's fine. Area of a circle is pi r squared. So they're telling you if they give you an angle divided by 360, and that's like a percentage, and that's how you find a sector, the area of a sector of a circle. Isn't that cool that they're telling us that? So look what they're saying. Let me draw it for you. Use the formula above to find the area of the sector where theta is 300 and r equals 8. So here's my circle, and here's my angle, and I'm going to try to do it. Okay, so they want this area here. So how did they do it? They go, well, treat this as one. The full circle is 1 revolution, 360. So 300 degrees over 360 gives you a percentage. Gives percentage, see? And I'm going to multiply that by pi r squared. Pi times 8 squared. Isn't that cool, guys? So I take my calculator. I go 300 over 360. So alpha y equals, for calculator. 300 over 360. And I'm going to multiply that sucker by 8 squared or by 64, whatever you think is easier. So, and then put a pi in the front. 160 pi over 3. 160 pi over 3. And if I have units, put units, square centimeters. So if you see cm squared, you're not going to say centimeters squared. You're going to say square centimeters. Chop, why? I don't know. When you look at the floor, do you count these tiles and do you go, oh, those are 8 tiles squared? Or do you go, those are 8 square tiles? Yeah, when you go to Home Depot and you go and you ask them, like, sir, I want 25 tiles squared. Like, they're going to look at you and be like, no, you're going to say, I want 24 of those square tiles. 24 square tiles. So if I'm sure Winters calls it correctly, but if Mr. Winters calls that centimeters squared, just Mr. Winters, it's square centimeters. He knows his stuff. He's good. Yeah, I know. In case you're Mr. Winters, if you're listening to this video, you can see I'm not throwing shade, but these guys always want to create drama. All right. Mr. Winters is the best. Mr. Winters is the best. See, this is record. No, look, these guys are creating drama again, man. Okay. All right, here we go. Next one, guys. A sector of a circle has central angle 3 pi over 4 and area 243 pi over 8 square feet. Find the radius of the circle. Okay, so now check it out. I love that they did this. What's up? No, tell me. Yeah, we're going to do keep, change, flip in a little bit. Check it out, guys. They didn't give me the formula, but they expect you to know, like, well, do the little fraction thing. This time they're in radians. They're not in degrees. So if I'm in radians, 1 revolution is how many? So I'm going to put, here's the formula. Theta over 2 pi times pi r squared. There it is. That's my new formula. I just adapted it depending on the situation. The other one was in degrees. So here we go. What do they want? They want me to find radius. So I'm going to type this in first. 243 pi over 8. Well, I was going to put the units also, but I'm going to leave it. All right. So here, you know what? You see this pi's? Can I cancel them out? That way it makes life just a little simpler. Theta over 2r squared. See? So here we go. I'm going to type in this. 3 pi over 4 divided by 2 r squared. So catch up to here. What's up? Okay. Can I'll hook her up. Okay. We're okay so far? All right. We're done with pre-cal, guys. The rest is just basic arithmetic here. Keep, change, flip with the 3 power 4 over 2. I guess you can also bring the 2 just up like that. It depends on how you learned it. So 243 pi over 8 equals 3 pi over 8 r squared. Can I cancel out those 8s in the denominator? Oh, you know what? But what if it wasn't an 8? Okay. I will do it the way, because some of you might have it different. So yeah, I stopped. I haven't written anything. No. Yes, I just keep change flip. Look, I'll write it over here on the side. Oh, okay. Well, for my fans. Okay. All right. I want r by itself, guys. Yes, you can say divide by 3 pi over 8, but I like to just, if anytime I have a fraction, I like to just say multiply by the reciprocal. So I'm going to multiply by 8 over 3 pi. Whatever you do to one side, you do to the other. 8 over 3 pi. So here's what I'm going to get. Ooh, pi. All right. 8s cancel out. The pi's cancel out. And I get 243 over 3 equals r squared. Let's see what 243 over 3 is in my calculator here. 243 over 3. And look, I get a pretty number. 81 equals r squared. Yep. What's my next move to get r by itself? Can we do that, guys? Okay. Okay. You good? You're not starting any beef? Miss, I'm a vegetarian. Okay. I'm not a vegetarian. Okay. All right, here we go. All right, guys, come out. We just have two questions, and these are what we've been talking about. A car has wheels with a 10-inch radius. If each wheel's rate of turn is 3 revolutions per second, find the angular speed in units of radians per second. So, guys, I didn't even need the 10-inch radius. By the way, that's a normal vehicle. A normal vehicle has probably rims that are 20 inches in diameter. So you didn't even need that, guys. You take the 3 revolutions, so 3 revolutions per second, and I'm going to go in 1 revolution. How many radians do you cover? 2 pi. 2 pi rad, and look, the revolutions cancel out, and you get radians per second. What's 3 times 2 pi? And there it is. What do you mean you don't understand it? Tell me. No, you understand it. This is just like in chemistry when you were doing stoichiometry. No, I'm not going to gaslight anyone. I don't gaslight. All right, what's up? Well, you start by what they give you. What did they give you? They give you 3. No, I'm not trying to. They give you 3 revolutions per second. So that's it. They only give you 2 things. They give you this guy and they give you this guy. The 10-inch radius is not going to be used right now because they want radians per second, not inches per second. So you start with the 3 revolutions per second, and you say, well, 1 revolution is 2 pi radians, and that's it. See?
So say they said per second 3 revolutions, what per second on top?
Okay, say it again.
So say the
Per second, 3 revolutions. No, I don't think that's a customary unit per second revolution. Second revolutions, no. Usually it's revolutions per second. But if they wanted seconds revolutions, then you would have seconds in the top and revolutions in the bottom. Yeah. All right, next one. It's the same problem again. A car has wheels with a 10-inch radius. If each wheel's rate of turn is 3 revolutions per second, how fast is a car moving in units of inches per second? So inches per second is linear velocity.
It's distance over time.
Distance over time. There's 2 ways that you can do this. You can go from your angular velocity to radians to feet, or you can go from 1 revolution covers the circumference, like the entire circumference. Both are going to yield the same answer. I'll do both of them. You tell me which one you like best. Ready? I go 3 revolutions per second. And in 1 revolution, there is 2 pi radians, because that's what we just did. And in 1 radian, how many inches? What is my radius? Because radian means radius. 10 inches. And there it is. And you can go 3 times 2 pi, which is 6 pi, times 10, 60 pi inches per second. Don't worry, I'm going to do it differently right now in a little bit. Say it again. Yes. You can just go right from the previous problem because it is the same question. Chab, I don't like that. I don't like that method at all. Okay, then you can think of it like this. Do you agree that 1 revolution is equal to 2 times pi times radius? That's my circumference. This is the circumference of a circle. Do you guys agree? So you could have done this. You could have said, I could have gone 3 revolutions per second. And in 1 revolution, you cover, what's the distance you cover? 2 times pi times 10 inches. And then there it is. You got inches per second. But notice, it's the same answer. Do you guys notice that? See? It's the same answer. So however you like to think about it. Because really, 2 pi radians is your circumference formula, 2 pi radians. And then 1 radian is your radius.
So you don't have to.
Make sense, Angie?
You don't have to do a whole other column.
No. Okay. All right, guys. We got 40 minutes. We got